that brings us to the rule, the power rule that we just talked about. Okay. So if I'm taking the derivative of any power function, x to the nth power, its derivative is going to be n times x to the n minus 1. It's true for any real number other than 0, so that's also going to be true for integers. Not necessarily just positive integers, it's really true for any power. It's not even true for integers, it's not even true for positives. I can expand this, and I will expand this for negatives as well, and I will expand this for rationals as well. So it's true for any n other than 0. And we'll see that rule expanded later on in the section. Okay. So true for any positive integer, but also true for the negative integers, and also true for rationals. All right, so to round this off and make another somewhat obvious rule, if you have a constant times a function, you can factor that constant out, and the derivative is going to be that constant times whatever the derivative of the function would be. So that's the constant multiple rule. Now we're going to use some of these rules in some practice here. Okay, use the above rules to evaluate the following derivatives. Now we see several different notations here for evaluating the derivative. So first, I want to take the derivative with respect to x of 4 pi. That with respect to x tells you what the variable is going to be. Since x is not present in this statement, 4 times pi is a constant. There are no variables in there. And from the previous page, we know that the derivative of any constant is 0. So this derivative is 0. Okay. This is the derivative with respect to s. I do have an s right here, so I'm going to be using the power rule at the top of this page and the constant multiple rule. So the derivative is going to be 2 times the derivative of s to the 6th, which is 6 times s to the 5th. So altogether, 12 s to the 5th. Power rule, bring your power down, take 1 off the power, so 6 minus 1 is 5. Okay, so that's the derivative. This is an alternate notation for the derivative. Again, it's saying take the derivative with respect to x. We mentioned earlier that you can do this for any power. It doesn't have to be positive, it doesn't have to be an integer, and we're going to see that this really is a power of x. So this is the same thing as asking me to take the derivative of x to the 1/5 power. And since I can write it as a power, I can now use the power rule to bring the power down 1/5 and subtract 1 from the power. 1 taken away from 1/5, 1/5 minus 1 is negative 4/5. Okay, that's fine to leave it this way. Also, you could rewrite that negative power, throw it in the denominator. You could write that as 1 over 5 times x to the 4/5. Or, because you originally started in radical form, you can go back to radical form and say this is 1 over 5 times the 5th root of x to the 4th. Okay. Right now, it can be in any of these 3 forms, but as we continue to work with these forms, we'll want to be able to change between one and the other depending on what the problem is asking us to do. So knowing that all 3 are equivalent is going to be important as well. Okay, let's finish this page. We have the derivative with respect to a of 3a squared. Now, I cannot do them together. I don't have a rule yet for doing the derivative of a compound power rule. So instead, I have to simplify right now. There is a rule that we will get later on called the chain rule that will allow me to do this separately. But for now, evaluate 3a squared as 9a squared, and then use the constant multiple rule in conjunction with the power rule. So now I have 9 times the derivative of a squared, which is 2a, or 18a. Notice if you just use the power rule from the beginning, the 2, and then take the power down 1, you would struggle to get that 18. So we really need to multiply that out first to get the correct answer right here of 18a. Okay. Now, in this next one, again, it's very similar to part C, where I could rewrite this and have a power of t right here. So I'm going to rewrite this as the derivative with respect to t of, that fraction is 2/3. Leave that fraction alone. That t in the denominator can be written as t to the negative first power. Okay, now when I do the derivative, I have 2/3 times negative 1 t to the negative 2. Bring the power down, take 1 off the power. Negative 1 minus 1 is negative 2. If I simplify, this is negative 2/3 t to the negative 2, or putting that in the denominator, because the power is negative, would be negative 2 over t to the positive 2. Usually, we'll get our powers positive. It's okay to leave them like this right now, but we want to be able to go in between the two forms. Okay. One more note while I'm on this notation. Before I take the derivative, I'm going to make sure that I am still writing the ddt to say I haven't done any derivatives yet. I've rewritten the function. This is still the original function, just rewritten. Once I take the derivative, not writing ddt anymore, I've done the derivative. I'm also changing my color just to make an emphasis there. Similarly, in the last part, f here, this is the derivative. I need to rewrite this. This is a function I want to take the derivative of. I need to rephrase. I need to rewrite this first as negative 2 times u to the, it's in the bottom, so negative, square root 1/2 power. That's the function I want its derivative of, so I'm going to take its derivative. So I have negative 2 times, bring your power down, negative 1/2, u to the, negative 1/2 minus 1 is negative 3/2. If you simplify that, it's positive 1, u to the negative 3/2. If the question starts with a radical, you turn it back into a radical format. That's going to go into the bottom and be the square root of u cubed. Square root of u cubed. That's just a square root there. I started writing the 2 for the index. We don't need to write a 2 index for a square root. Okay? So that would be our derivative. Last note, just to throw up something, is I stopped watching my x's and s's, etc. But if I was ever asked to do something like the derivative with respect to x of 2s to the 6th, because s is not x, this is a constant with respect to x, so it would be 0. So in order to do the derivative, you want to make sure that your variable in the function matches the variable in the derivative.